Hey y'all, hope you're having a good week. It is Friday, everybody's best day. We are going to start on page 8 of the notes. Remember also, if you need them, you can wait till 4:30. They will be there so that you can push pause every time you need one. So let's get going on those. So Ode to Tease. There once was a man named Gossett who looked for his Z's in his closet. Remember, last 2 units we've been using Z-score, or in hypothesis testing, we use Z-score. There were no Z's, but only T's. So he put T's in curves and loves it. And so William Gossett worked for Guinness Brewing and experimented to make the beer better. Data sets were small. Probabilities did not fit those of the standard normal curve. So he created T distributions to use in his work. So on your calculator, what we want you to do is go to Y1, put in normal PDF, and instead of for the x value, we want you to use the variable x next to alpha. Okay. And paste that in. And then in Y2, you are going to do TPDF. And that is TPDF is in second vars number 5. So push that. And your x value is going to be x, the same x as you found before, and your df is going to be 2. And then you're going to click paste, and then you're going to go to window, which is next to y equals. And you're going to type all this information in, and it is a little skewed. This should fall under, that should be over there. So you are going to do a negative 4.5, positive 4.5 with a scale of 1, negative 0.0 or 0.1, 0.5 with a scale of 1, and then you're going to hit graph. And what you should get, oh, hold on, I think I scrolled up somewhere. Here we are. What you should get is 2 curves. What you should be looking at is 2 different curves, a blue one and a red one. And the T distribution consists of standard T's centered at 0, bell-shaped, that extend from negative infinity to positive infinity. A T statistic tells you how far the sample mean is from the population mean in standardized units, and the T distribution are based on degrees of freedom. And that's what we're going to be working with. So your degrees of freedom is based off of n minus, or is equal to n minus 1. Independent variables are free to vary. So suppose that in your statistic class there are 4 tests in a grading period, and assume the grade on each test is independent of grades on others, which ours are. You want to have a test grade average of 80. So here you are, here are your 4 tests. What grade can test 1 be? Well, it can be anything, right? Is it free to vary? Yes, it is. It's free to vary. At this point, there is no judgment on that one. What about test 2? Is it free to vary? Yes, it is. What about test 3? Is it free to vary? Well, at this point, It is free to vary. So right now, all of those are free to vary. But at this point, you know you need that 80. If you want the test average 80, can test score be any grade? Well, no, at this point it cannot. It's locked into one grade or higher, well, one grade to have an exact 80. It could be higher than that grade if it was more than 80. So is it free to vary? Not at all. It has to be a specific grade in order to have a test average of exactly 80. This concept of DF, or degrees of freedom, is similar to the example below. So the T distribution corresponding to any particular number of degrees of freedom is bell-shaped and centered at 0, just like the standard Z. So if you look, the blue is the Z, and the green is the T curve for 2 degrees of freedom. Each distribution is more spread out than the standard normal distribution, thus there is more area in the tails. So why could that possibly be? Well, let's graph it. So in T, so go back to Y equals and go to that TPDF under second vars, and again keep X, but this time make your degrees of freedom 5. So what happens when you graph it this time? So you should have a third color, mine is black. So what's happening is, as the number of degrees of freedom increases, the spread of the corresponding T distribution decreases. So what ended up happening for me is that third piece kind of went in this picture here and went in between. Ooh, undo that last little bit. It was above the green until they met, and then it went below the green. So the area below is a little bit lower. So as the number of degrees of freedom increases, the corresponding T distribution approaches the standard normal distribution. And that's where it mellowed out. Oh, wait. Let me go back. Let me pull this back a bit. No, I just wanted to start here. So that red in there that I drew in that magenta, the previous slide, that's where that red fell. The T distributions are robust, in other words, less affected by skewness because of the more area in the tail. So they are less affected. So let's recall some ideas from when we dealt with proportions. The statistic we used for the sample proportions was p hat, and now we're finding the sample mean. So that statistic is x bar. And instead of calculating a z-score, we will calculate a t-score, and we'll talk about that some more. So to calculate the confidence interval for proportions, we used p hat plus or minus m. So now with means, we are going to use x bar plus or minus the means. So the last time we did confidence intervals, everything we did was with p hat and z-score, a margin of error. This time, we are going to use means instead of p hat, t-score instead of z-score, and m is going to be the same, but there's going to be some slight different calculations. We are also going to introduce the calculator a lot sooner than we did the last time, mostly because you have already done all of these confidence intervals with proportions. We are just introducing the words means, t-score, and that type of stuff. So proportions use z, means use t's. This is going to be huge when we get towards finals and the difference in those, especially for my juniors. So that is where we are going to stop, I think, today. Hold on, let me see. Oh, nope. We're going to use these for today. Nope. We're going to pick this piece up on Monday is where we're going to start with this slide that I have tapped through. I am looking at your homework now. Your homework now all has to do with means, plus margin of error means minus margin of errors, calculating those based off of given confidence interval, and calculate your margin of errors based off of given confidence interval. And then they're going to give you some information talking about standard deviation and all of that, just like we did before. And then I will see y'all on Monday, and we will pick up there. Have a great weekend.